All right, our second lecture in Calculus 3. And so just like last time, I'm going to parallel the instructor side with the answers and stuff with my student side. And you're like, that doesn't show any answers, Chad. I know. Just in case, though. I went through it already yesterday, and this is a super easy topic. I'm going to hopefully not get anything wrong, but you never know. Vectors. We talked about vectors back in pre-calculus. It's been forever. Let's just assume that we don't know vectors. You probably have seen them in physics if you have physics, let's just say. But let's just assume you don't. So from the very beginning, if you're bored, I'm sorry, but here we go. Vectors. I always use V as a nice one, V for vector. It has a little arrow thing on the top. And the reason why is because vectors generally are bold, and I don't like doing this every time, right? So just to really quick do vectors, I just put a little arrow on the top, and it says that's a vector, okay? We got U vector, we got V vectors, we got W vectors, all that kind of stuff. But these are the traditional letters that we use. U generally stands for unit vector, which means its distance is only 1. So it's always a 1. But that's not always the case. I know that traditionally on the homework, they'll just throw a U in there and, ha, 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 you know what this is, and then you don't, and then you do, and then it's weird. So just don't, you can't assume it means unit, but when I use U, it's generally unit, generally, hopefully. I know it's kind of odd. So what is a vector? We're going from initial point to terminal point. And so very quickly, the formula is terminal minus initial. That is the big formula of the day. Terminal minus initial. So as an example, let's just say that this point here was at 3, 5, and over here, let's just do 1, 2. Just, making up numbers. So I'm going to write them in little alligator forms, but it's the same idea. So terminal was 3, 5. And initial was 1, 2. And now I just do the math. And it doesn't take a lot of thought here because what we're doing is just kind of combining the like terms in a way, So the x's with the x's and the y's with the y's. And so y'all already have an answer. What would be my answer for this? 2 and 3. Perfect. You got it. Exactly. It's super easy math, right? It's just knowing the concepts of how to get to that. So exactly. 2, 3, that's would be our vector. So that's our movement from A to B. Okay, so I would say like this is A to B vector. That's another way to notate that. Cool. Of course, that's not the scale, but we just do what we can around here. Good with that? To find the magnitude, and I think that's probably on the next page. Oh gosh, I forgot. I have the printed versions next door. They're ready for me. I just didn't go grab them because I was at the data thing. Okay, pause for a second. Do you want me to run and go grab those? I can while live streaming. Let's do it. I'll be back. Go for it. Well, let's see what you guys think. You write a review for me. You remember this. Okay. I'll take care of that later. Oh my gosh. All right. So, y'all have the workbook now. Okay. Brisk run in the cold. Okay, so we're good. So, all right. Terminal minus initial. Great. So, oh, look. We were already talking about vectors. So, bold. These are little alligators instead of the point thing. The parentheses just mean point. Alligators mean vector, right? So, that's how we denote it as we keep going. It's great. I'm just kind of catching my breath. I literally write, okay? That's what I do for my students. Magnitude. So whenever you have this absolute value looking thing, it's meaning the distance. So they're saying distance here. And I think that's really cool, but why is it the absolute value sign that they're using, right? Let's do a little bit of theory for a second, if you don't mind. Let's say that I have I'm sorry, I'm just trying to catch up here. What if I had the absolute value -2? What is that? 2. What's the absolute value of just positive 2? 2. All right, so basically on our number line, from 0, if I go to positive 2 or even the -2, the distance was 2. So in a way, I'm saying absolute value kind of already shows me distance on a one-dimensional plane in a way, yeah? So now I'm just going to go two-dimensional here, or even three-dimensional with the same concept. So that's what they're doing with all this. Let's just say that I get rid of the other dimensions here on this for just a second. Yeah, and let's do some math. V1, the original, right? But even better than the original. Think about it like this for a second. What if I had the square root of -2 squared? Yeah? So then I have got the square root of positive 4, right? Because 2 negatives make a positive. And the square root of 4 is 2. Notice that my -2 went to a positive 2, right? Again, what did I just do? Absolute value. I just did absolute value. And so what this is doing is making absolute value, finger quote, for extra dimensions. I'm just doing it now for other dimensions. Cool? So that's kind of what's going on. Now, I gotta say, I'm not a big fan of the single bars because I think absolute value, I don't want to think that here in Cal 2 or 3, Cal 3. So what I do is the double lines often, and that's the same as saying single lines. So if you ever see me do double lines, it's the same as the single lines. I'm gonna catch my breath. I'm gonna get there. Until then, I'm just kind of. All right, what's up? Why is there no positive or negative in front of the 2? Positive or negative in front of the 2? Plus or minus 2. Yeah. Oh, I understand. Yeah. You're talking like algebra. Yeah, forget about that. So no, no. Because again, we're thinking distance, right? And so in the end, we have to consider why are we doing it? We're doing it for distance purposes. Same with the radius of a circle, right? If I had a circle, this is the same formula for r. If you didn't notice that, if I had a radius and I said, "Oh, my radius is -2," you're just confused, right? It doesn't make a lot of sense. So the purpose of what we're doing it for implies positive only. Very good though. I like that. Yeah, that's good thought. So yeah, we just stick to the positives. Excellent. So adding, multiplying vectors, very simple. In case you've never seen it, basically you can just add the two numbers together, or you just distribute, right? So that k gets distributed to each one of these. Hold on, that didn't look good. So the k is in the front, and then you got a k for every single guy. So very simple stuff there. All right, moving on. Oh, unit right here. Whew, finally got it. So unit vector is, again, denoted normally with u, but they say it's v over magnitude of v, and that's a good formula. I like that a lot. Basically, I'm dividing by its original distance so that I can get its unit distance, its one distance. So going back to my 2, 3 result, what I'm going to do is divide by 2 squared and 3 squared. And so then I've got the same vector at the top. And then what is that? 4 and 9 makes 13, square root 13. So my unit vector would look something kind of like this here. Now I know that looks funky and you're like, ew. But let me show you what that looks like in Desmos if I can. How could I? Oh yeah, I know how to do it. Okay. Let's do 2, 3 as a point. Again, I know it's not a vector, but do they do vectors? That would be really cool if they do vectors. I doubt it. Yeah, okay, let's just do a point right now. 2, 3. And then I'm going to do this weird one. 2 over the square root of 13, and then 3 over the square root of 13. And if you're noticing here on this, this was my original, and that's my new one, right? But they're in the same direction, yeah? That line is the same from the origin, yes? But what's the distance from the origin to this? If you're able to do a distance formula here, there would be 1. It's a 1 distance. I'm going to try to do. This is a 1 distance. Yeah. Cool. You see what I'm saying? So this is a 1 distance rather than the other one is, I don't know, a distance, square root 13 or whatever. So that's how we're finding unit, is by just dividing by its distance. Cool? Okay, cool. I know this is all kind of basic, but I just want to make sure that we're getting the foundations, So let's do one here, and then y'all probably do the next one or something. So it says, what's the answer to this stuff? So I got 4 times, and then I got my 4, negative 2, and then minus 2 times, and then negative 6, 2. Notice they're using U and V, but U is not necessarily unit. Just see how they'll throw this on you, okay? It's not official, but we do try to use U for unit if possible. So what do I do with the 4 and the 2? Distribute, yep, perfect. So then I got 16, negative 8. And I'm going to do something a little funky here, okay? I don't know if you like this. I'm not going to do funky. No funky. I was going to distribute the negative sign, but then it would kind of throw off the look of the things. So I just distributed the 2, not the negative sign yet. I have a minus sign. What do I do between these guys now? I'm going to add or subtract them, exactly. So here in this particular case, like you said, there's 2 negatives to make a positive, right? So I'm going to say 16 plus the 12, and then I got the negative 8 minus the 4 to get 28 and negative 12. There you go. So that's my answer. It says find the magnitude of that. See how the absolute value signs again. I want to stress it's not absolute value, but that's the same concept. It's magnitude. That's why they'll say magnitude. Modulus is another word for it. So I'm going to do the square root of these guys. Yeah, I'll do this for now. Like, that's my answer to part A. And then for this guy here, calculator. Definitely. Do I need that minus 12, or could I just write a positive 12? Yes, exactly right. So when I'm doing my math, I mean, to heck if I actually have to wait on typing negative 12. It's just 12. I know it'll be 12 because of the square, like you said. Now, I didn't get a very nice answer, and they're saying find radicals and stuff like that. So this is back from pre-cal and all that stuff. We just basically remove the square root sign, and then we're good. So I'm saying just look at the inside number. And again, in this class, I've been promised that it should be just square root 928. Good, excellent. Okay then, yeah, like back up. Sure, right here, unit. So I was just doing like a little demo of how to find the unit vector. Oh yeah, please do. I'm all about that. Yeah, no problems. That's what we're here for. I'm like really super hot. That's okay. It's okay. It's fun class. I guess I forgot to talk about the midpoint. I think there will be a question about that on the homework, but you just divide by 2 when you add them. Add them up, divide by 2. That's how you find an average as well. Midpoint, average. You're good? Okay, good. Thank you. Yeah, midpoint, average. But again, we'll see that in a few minutes. All right, cool. Are y'all seeing what I'm seeing? Good. Yeah, good with what we're doing. Okay, good. So, hey, look at that. You guys get to do this one. Yeah, that would be great. So y'all do this guy. Find the vector that it would be using those 2 points. I told them to put a cover on this thing. Sorry that has no cover. Yeah, I told them to just put something on there that's not fancy. And they put nothing, because that's not fancy at all, right? Just don't put anything. And again, I'm not ever looking for y'all to like get 100% on this stuff. You know, I don't either. And not even having to finish it in the time that we would say. I'm just wanting to make sure that you're on the right track. Like, what's step one? What's step two? You know, it's like the idea of this stuff. And I mean, I haven't done the math on it, but it seems as if once you get like step one, step two down, you know, and you know kind of where the direction's going, they almost always at least get really close to getting it. You know, the hardest part of a math problem is literally the first step, knowing what to do. So, all right, I know y'all have an answer for me. Yeah, yeah. Oh. Okay. Like, there should be three numbers, right? They can't hear you. It's okay. I'll just write down what you said. Sure. Go ahead. Cool. Let's check it out. So going from P1 to P2, basically they're saying I'm starting at 1, I'm going to 2, right? And remember that this is always terminal minus initial. And so what's actually going on is I'm saying P2 minus P1 in a way. It's okay. No, it's good. So that's kind of like the formula for it. And so then I would say my P2 is over there, -6, 2, 2. And I'm going to subtract. And then I got the 5, -4, 7. And we put it together here. So I've got -6 minus the 5 would be a -11. And then we got 2 minus a -4. And we have to always distribute, right? 6. And then 2 minus 7 is a -5. Sorry. But that's good, though. I'm going to go and double check with the instructor side because, of course, I want to make sure I'm doing the right thing for y'all. So we had the previous one, right? So that's good. And then this guy, 11, 6, -5. Yeah, we're good. So I know that they're a little different. I can't always get like 5 of the same thing on here because we just don't have enough space and time and all that stuff. But it's good to kind of test out, do little things like this. Making sense though? Yeah. I know the math is pretty easy. It's interpreting what to do, right? That's the biggest thing right now. But yeah, once you get it, you're like, oh, got it, no problem here. And notice you were saying I, J, and K. So I didn't touch on that, but the true answer for them is going to be with I, J, and K. Obviously, they have 3 separate boxes, so it doesn't matter right now. But they use I, J, and K to kind of just delineate A, B, or A, B, and C, X, Y, and Z, that kind of thing. Notice that there's a difference. So whenever I say I component, I have a little hat on him, component, versus a vector has a little arrow thing on the top. So they're a little different notation. Again, all they do in the book is bold. So I can't do bold, but I can do a hat. I can do an arrow. And it tells me it's not I arrow, it's I hat. So it tells me it's a component when I start doing a lot of craziness here a little bit. Cool? Good? Okay. Keep cruising, I guess. Do you know where the I, J, and K came from? Why do we use those letters? No? Yes, yes. I is actually imaginary. We actually started with all this back AI and BJ and CK because we just kept running out of letters. These are all imaginary numbers. I guess we would have started with like a real number R. There you go, plus. So it actually did start imaginary number stuff, but that's way back in the day. We're not doing that right now. If you do see imaginaries here, I don't think you will actually. That's a good thing, right? Good. Yeah, yeah. I don't think we're going to see that too much here. But I mean, you are seeing it. If you go and take, you're all math engineering people. You're gonna take complex variables one day, which is all imaginary numbers, and they use the same style that we do. They just run out of I's, so they use J's, and they run out of J's, so they use K's, and just so what you do. It's kind of funny. Anyways, this guy, direction. Oh yeah, so we just did one like this, and then they're on the midpoint. Notice that we go from 1 to 2. So then we're going to start with 2 and go to 1 in a way. So 4, 5, 0, and then negative 4, 4, 2. Trying to make it look better. Come on, man, make my 2 okay. Okay, there we go. So you help me right quick. I know y'all got the answers. What's the answer to this? 8. Good, and? Yep, negative 2, you got it. Perfect. So that's my answer. We're done with that. To find the midpoint, they're wanting to take the 2, add them up, divide by 2, right? Just like we had an average. So I'm like, hey, find the average between 4 and 6. So we add them up, divide by 2, and we get 5, right? That's the same idea for the midpoint. And so you have to like take each individual one to do this. So 4 plus a negative 4 divided by 2. But what would be the midpoint between 4 and negative 4? 0. It makes sense, right? Doesn't it? Isn't that the middle? Isn't that the average? Same with all of these. So it's like a whole brand new formula you have to do every time. 9 over 2. I'm just going to keep it 9 over 2. It's looking a little sloppy there. And then finally, 0 plus the 2 over 2 is a 1. And like every time, it's back to the number lines. So like we have a 4, we have a 6. So where's the midpoint? It's 5, right? Just it's all visual. So what they would want you to put in there again, that looks sloppy. It was my stylus thing wasn't working. 0, 9 halves, and 1. Let me just verify that we're doing it right. And yep, there we go. Cool. Why do they have the little square roots on this? Ooh, isn't that annoying? This is why we have the instructor version, because I'm gonna go get it wrong. Technically, right? You see? We had the right numbers, but they wanted something else. What did they want? What did they want with these square roots? Just take a guess. Unit. The unit. Did they say unit anywhere? No. But see how that's just what we're gonna have to deal with. It's you and me. It's both of us. So they want the unit, I guess, because they're saying find the direction of this stuff. I guess. Okay, fine. So like on your homework, I'm gonna face the same problems as you guys, and let's just say on exams, right? You put this down, and the answers would divided by square root, blah blah. I mean, that's you and me both now, right? So we would have to find the unit vector. So like direction unit. So let's do that. Let's find the magnitude of this. So I would do 8 squared, 1 squared, 2 squared. 64 plus 1 plus another 4, 64 plus 5, 69. Was it 69? 68. 4. See, this is why I need to do like math. 69. 69. They said 69. I'm saying 69. 69. So that's what they're wanting you to divide by each one of those, I guess. Wrong today. Darn it! I even looked through everything beforehand. Y'all okay so far? Okay, cool, cool, cool. Okay. Um, so this is interesting. We have find A and B given that they want us to do this kind of vectory thing. Okay. This is actually a system of equations. It's brand new for us. It's like we have to kind of go backwards on it. It's very weird, but fun. So they say that we have this U, the V, the W, and we basically got to plug them all in. I'm going to literally just plug them in to this little equation thing and just look at what we got. So I've got my 8, 2 is equal to A times my V is a 1, 1, and my B is a 1, -1. I'm pausing right there for a second. For one, I am not using I and J. I don't like it as much as other things. I like the arrows because we're used to, or the alligators, we're used to points anyways, and I's and J's are just going to get in the way. I feel like having them separated like this helps our human eyes a little bit. That's up to you. There's time and place for I, J, and K. But do you see how we're going to have to group them? It's like a grouping, isn't there? Please. Yeah. Yeah, you got it. Basically, if there's no number there, that's a 1 technically, right? And there's a 1 and that's a -1. Cool. Very good. Very good. Very good. So I'm going to look at just the X components, and I just want to look at those individually. Now, I can't just do that right now. I've got to first distribute and, simplify and stuff like that. But eventually, I should get 8 is equal to 1A plus 1B, basically. And then looking at the Y components, I got 2 is equal to 1A minus 1B. And I'm going to label those. I'm going to say X's and Y's. I like that. X's, Y's. Do y'all remember doing this in partial fraction decomposition? Ha ha ha, yeah. But at least at this point, this is the easier side of partial fraction decomposition, right? This is like the whole hard part was done. We just needed to figure out the last little bit. So that's nice, but you see those skills are still there, right? So what do y'all think? What would y'all want to do to solve this? Yep. Yep. Substitution method, basically. Yes, I like that. That's good. Does anybody want to pull up a matrix? I'm just playing. I mean, you could. I don't think that it would be helpful to you in the end because it's just this one-off problem, right? Yes. Yes. Oh, that's right. That's very good, actually. I think I want to do that because that's like cooler. Yeah. I mean, your style was cool too, bro. Okay, that's like what I would normally have done. But yeah, addition method. Oh yeah. So if we do a big old plus sign right there, boom, we get 10 is equal to 2a and then plus 0, essentially. Perfect. I love that. Divide by 2, and we got a is equal to 5. That was super fast. And then I could plug that back in. I want this guy. So 2 is equal to 5 minus b. And I'm going to move the b over, move the 2 over. 5 minus 2, b is equal to 3. So there's the two answers from that. And I'm finding that I like checking myself, if that's okay. And so I think having this parallel is really cool. 5 and 3, we're good. That's, yeah. So far, that's been helpful. Okay, good. So, yeah, yeah. Oh, yeah, yeah. This is good. So, cool. So we're gonna have these one-offs. I wouldn't say this happens very often, but it's a thing. Are y'all okay with this? Is this good? Yeah. Cool. not scary math yet until this one. So when I saw this yesterday, I actually wanted y'all to do this one, and I don't know if I should set it up a little bit and then have y'all go. No, I want y'all to just look at it for a little bit. Y'all attempt. Like, I'm not expecting the world out of this. I want to just see maybe pictures. Draw a picture. There you go. Draw a picture. I want to see if y'all see what I'm seeing. Like, are we seeing the same picture? And then from there, we can kind of analyze what we're seeing, you know? I know, like, some of y'all are pure math, let's just say, but some of y'all are engineers. What do engineers do? They draw pictures. Yes, they do. They do. They do help. See if I can zoom in a little bit more. That's kind of small. Definitely not expecting answers. Just wanting to get your brain drawing pictures, I guess, thinking about what it could look like, maybe, you know? Expect that there will be a what? I'm here for you. Oh, there you go. Yeah. Oh, yeah. That sounds pretty legit. Maybe we should be using some sine and cosine. Yeah. So, like, I know that the workbook it's going to be okay, but it will certainly not cover every problem on your homework. You know, there will be a word problem or two that just pops up like this. Like, Chad, you didn't prepare me for this. And I mean, it's right. You know, sometimes we got to try to figure it out a little bit. Okay, I'm going to draw a picture and see if y'all's pictures line up with my picture. So I got an airplane. So this is what an airplane looks like to me. I am not kidding you. It's okay to draw pictures. So I got a airplane, and it's traveling 35 west of north. Okay, hold up. So I know that north is this way, and I know that west is going this way, right? So it's going 35 west of north. So, like, from the north, I'm going this way 35 degrees. That's at least how I'm interpreting it. Kind of close, maybe? I think that's what they're talking about. I'm not 100%. We're going to see as we keep going, okay? I think that's it. And it says we're going 700 kilometers per hour. I'm guessing that's fast. I mean, it's an airplane. It's going to go fast. Find the components where it's the x and the y, basically. So they're just wanting to know what's the x component and the y component for this stuff. Now let's go back to pre-cal. I have a degree, yeah. So I'm thinking trig, sine and cosine probably. What is associated with x? Cosine. It's cosine, right? And then so this one would be sine. And there's one small thing that I add in there. Y'all haven't probably had me in a while, or if not at all. I added an r in the front. X is equal to r cosine. Y is equal to r sine. So that's your formulas back way back from pre-cal. So that's what I want to do. I want to find my numbers that just apply, and it should be good. So we got the 35 degrees. That's definitely my theta, right? There's no problem there. But I'm thinking that the other number, like, because there are no other numbers, this guy's right here. He's got to be my r, right? My radius, my distance, my direction. Not direction. What's that? Oh, okay. And did they say 1 hour? They just said velocity. Yes. Well, that's true. Right. Very good. And if they did say, hey, how long did it, or how far did it go after 2 hours, then we would say just multiply by 2, right? Excellent. I like that. Just slap it in there. It'll work. So I'm guessing 700 cosine 35 and then 700 sine of 35. Why is that wrong? Good. My 35 is way up over here, right? That's not the right angle that we start with. And when we're doing trig, we got to start right here and go this way, yes? So if I were doing 35, I'd be going this way. That is totally not the same direction. So in a way, we got to like redo our angles a little bit, yeah? So what would it be then for, if this was 35, how would I find the full distance here? Yes, there we go. Add 90 to it. Yep. So I'm going to say not 35, but 35 plus 90, so that I get, I guess, like the true unit circle direction kind of thing. Which I think, like you were saying, the 55, when you do the math, it actually ends up that way. Exactly, because of the quadrant you're in. Perfect. That's exactly why we draw pictures. So we know I'm expecting to have a negative and a positive in a certain way. Very good. Yes. I like that. So yeah, this is definitely going to be calculator. I know you've heard this. Make sure that Desmos is in degree mode for this. And later we're going to use radians, of course. So watch out for that kind of thing. Let me get a little bit more room here. And it says decimals for the answer, so it's happy with just what you got there. So no big deal. And yes, I did get a negative x, and I got a positive y. So yeah, we're good to go. I'm happy with those. I'm gonna real quick verify, just kind of flash it up here on the screen, and yeah, we're good. We got it. Awesome. Yeah, I really like having that instructor side. I mean, that way I know I'm doing it right, you know. And when I get it wrong, I can go back and say, well, why did they do that? Okay, sweet. So was this problem here is actually at the top, but we're going to see that. I'm going to scroll down right quick. It's right there. So this is the official dot product formula. We're multiplying each component together. Yeah. So all my x's get multiplied, my y's get multiplied, my z's get multiplied, and then I just we're done, and we add them all up, and we're cool. Notice this is a big difference between the cross and dot product. This will result in a scalar value. Okay, we're going to get a number, just a number. And that number is meaningful. Eh. So there was actually between, do y'all know, used to teach Cal 3 also. We would kind of go back and forth between this. And he actually like went on to a big spiel about what dot product was actually meaningful for, and there is a lot of meaning in it. I take it more as a component in the bigger picture. And so for now, the dot product, I need my dot product in order to find my angle. This and that. So it's like the wood to build the house. Yeah. He also has ideas about like the number means something, and it does, kind of, But I see it as a piece. Moving on. So that it's a very easy one. Let's just do an example so that we're all happy. So let's do 2, 3, 4. Dot 5, 6, 7. It's gonna be a huge number, but that's okay. So I'm gonna do 2 times the 5, and then I'm gonna do 3 times the 6, and I'm gonna do 4 times the 7, and I go to Desmos because I don't know what that would be. 10 plus 18 plus 28. Okay, cool. So 56. What does 56 even mean? Exactly. It doesn't really mean much, but we could use it to go find angles if we need to, okay? And other things. Make sense? So we're still multiplying, just that's the way it looks. I'm going to go back up to the angles now, okay? Are y'all good with the scalar dot product stuff? We're good? I'm going to scroll up. So angle. So the main purpose of using the dot product at this moment is finding the angle between two vectors. So in order to find this, there's your formula, and I'm just going to make the condensed version. I know it's probably right down there a little bit. So the arc cosine of u dot v divided by the magnitude of u times the magnitude of v. And this is where notation is very interesting. Notice I'm using a dot up here and a dot right there. But the dot up top means dot product. This dot right here just means regular multiply. It's okay. and that's just how it is. Notice that they don't use a dot in the middle, and that's fine. But then it has like a whole lot of vertical lines. So you just can't get around one notation or the other. You pick one, you go with it. By the way, just in case, arc cosine. I know that you already know this, but that's with the little -1. So I go back and forth. In this class, I probably tend to the spelling it arc cosine, but either way. Cool? So let's I don't want to do an example on that. We're going to see that here in a minute, but good with that? Yeah, I'm going to keep scrolling. This is concept right now. Projection, that'll be a good formula here later. I want to come back to it. I think we'll have enough time, but you never know. There's some other keywords right here. Orthogonal. What's another word for orthogonal? Do you know? You've never heard of that word before? Okay, perpendicular. Have you heard that one? Yeah, I can't spell it. Perpendicular. So, and this is the symbol for it. It's like it looks like a T that's upside down. Okay. I don't know why we have to have two words for the same thing. I don't know. You're going to see that in linear a lot. So it's going to be like, oh, find the orthogonal vector of blah blah blah, and then same thing. Okay, literally the same thing. Good. And so yeah, there you go. So perpendicular. They're saying that if the dot product is 0, that's what's happening. But if you go and do the arc cosine of 0 divided by blah 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 blah. So I got the arc cosine of 0. Here, look, I got a calculator. Arc cosine of 0 is 90. There you go. So perpendicular. That's my angle between the two vectors. It's one straight up and one's on the side. 90 degrees. Cool. So that's kind of what's going on there. We'll come back to this guy. I think we'll come back to this guy as well because there's going to be a formula about it later or a problem. So find the angle. I want to see y'all do this. I want to see y'all do this one because, again, the formula is not too hard. I can do the arc cosine side of things, but I want to see you do the dot product stuff and even the magnitude. There we go. That's the formula again. And there's one small thing I'm going to go ahead and tell you ahead of time. Your K, what's your value for K over there? 0, very good. So, yep. I want to see y'all get the dot product and stuff. You don't have to get the final answer. Y'all are the like most studious students in the whole school right now. Really. Yeah. Okay. Well, yeah. Even you, James. Yes. It's like I see like multiple color highlighters, all the different pen styles. You got your calculator, but you don't need that thing, but you're using your thing, so we're good, It's like, it's so funny. I see, I mean, this is being live streamed, but algebra folks, they're not always as particular as we are. I guess it takes a certain brainwave to get to this point, right? uh, true, true. Oh yes, many mistakes to get to this point. Yes. Fail upwards. Well, me too. I've done it all and still do it. Oh, man, I do that a lot because arc cosine has two C's. I often forget one of them. Okay. I'm gonna just start writing a couple things up here. Maybe you can see like how I like to approach it. Okay. I'm gonna get a little bit further down. Oh, I did it again. Arc cosine. Um, 36 and 0. Sweet. 9 and 36 would be 45. Are those two sixes? Bro, I can't. Sounds right. 88? Alright, that's cool. I'm just going to get the inside real quick. So, 48 on the top. And then I got this square root business on the bottom. No, don't need that. All right, awesome. I'm hoping that's good enough there. Did they say, yep, there you go, decimals. I'm going to real quick, I'm going to go back through it here. I just want to make sure I'm doing the right thing here. Scroll, scroll, scroll. Well, fine then. Oh, and it happened in pre-cal. It's going to happen here, All right, there we go. Plug it in, substitute, whatever you want to call it. So like it looks nasty sometimes, and that's okay. I know what I'm going to go towards. You can definitely do it on the side. You get the same results. But my dot product, I just start combining the like terms essentially and putting those together. In the bottom, you notice that I just did not write any negative signs because we don't need them, right? They're going to go away anyways. And that makes it a lot faster and a lot less symbols to get mixed up. So because we're going to be writing a lot in this class, we need to make sure to keep it as simple as possible. And then basically at some point I just gave up and I just went right to the calculator, and that's okay. That's how we do it, Are we okay with plugging in some stuff like that? Overall, not too bad, right? Good. All right, awesome. Okay, well, I'm gonna keep cruising then, I guess. We got plenty of time. So we got two different vectors. Oh, man, look at them square roots on there. They're wanting the dot product, and then they want it. Wow. Okay, that's fine. That's fine. So I think that we can easily do this stuff without, like, with what we already know, without me going back up to the formulas or anything like that. Okay. So let's just do what we can. The dot product. So it doesn't matter. U dot V, V dot U. It's going to be the same in the end anyways. So let me actually, I'm just going to do it. I'm just going to do it. So I got 6 and a negative 6 makes a negative 36. I got a 2 and a negative 2 makes a negative 4. And then we got these two guys. Again, I'm multiplying them. What do I get? Yeah. Yeah, -2, exactly. Square root 2, let's just verify, I'm multiplying them, right? So I got square root 2 times square root 2 is 2. And it's a negative because there was a negative there. What is it, -42 in the end? Am I right? 36 and 8. Man, y'all are making me doubt, bro. Okay, good. So that's my answer for that one. And again, that's nice. What does it tell me? Not much, just a number. The magnitudes. So going through the magnitudes here, I got the square root of 6 squared, 2 squared, and the square root of 2 squared. 36, 4, and what do I put over here? 2, exactly. You know what's kind of funny? Doesn't that look the same? Interesting. I wonder if I get the same thing right here. Blah, 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 blah. Square root 42. Yeah. Yeah. I think that always works like that. But it just so happened to be this time. Yeah, look at that. There we go. We got it. It's cool. Okay. Of course, now that I have all this stuff, I have this, I have this, I have this. All three of these can get tossed in to my arc cosine formula. So then I got the -42 up here, a square root of 42, a square root of 42. So I got my three different pieces of the puzzle. I put it all in. -1/1. So what's the arc cosine of -1? Calculator. Yeah, that's what I'm thinking too. Oh, there you go. Look at that. Or 180 degrees. So they want. Oh, look. They didn't want the angle. They wanted the cosine of the angle. I think that they're just wanting -1 here. Like what goes on the inside? Yeah, there you go. Man, isn't that tricky? That's that one of those little moments again. That's fine. But there we go. All right, cool. So yeah, 180 degrees. And so what does that look like graphically? It looks like we got a vector here and we got a vector this way. What's the angle between them? 180, right? So they're just going different directions. And you could see that, right? Negative, positive, positive, negative for each one of them. So what is it now to have the scalar component of u in the direction of v, blah, 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 right? I got to go look at formulas. I haven't looked at that yet. I haven't seen it yet, and I can't remember. Even the projection, I just skipped right over. So let's go back and look at this stuff. Are y'all good so far, though? Okay, so let's go back to look at the formulas and see if I could find that somewhere. So we got dot product. We got this projection of u on v. We got a work thing. So like we got a formula for this one. Did I just not put in the scalar formula? Ooh, I would be so angry at myself. It's the same thing? Oh, it's up there at the top? Oh, well, it is a scalar value. Yes. Where did I? Oh, the dot product. You're right. That was way back over there. I can't remember. Anyways, it is a scalar value, and that makes me think that. And like, look, let's look at the answer. It's this guy. But I think it's because there's that wording, scalar component of u in the direction of v. I think there's something going on here, and I don't have that formula. If you don't have a formula, we're gonna write it down. My workbook's not perfect. Let's go and find it on the book. So give me a second here to log in. This will probably be the last part then because we don't have enough time after this. But I want to make sure that you get this formula. I guess it just slipped by for me. I know that there's a formula for it though. I've done this before. It's one of those that I just don't see as often. Do I just click this? I don't like it. Okay, ebook. And this was 12.3. Yes. Okay, cool. Open the ebook. So this is how you do the ebook, by the way. There's an ebook link, and then you click it, and there you go. So I guess so. Yeah, let's just try to find it now. 12.3 load. 12.3. I'm going to look for the scalar of this and direction of that. And it might not be in gray. It's the same thing. If I can't find it, I'll scroll back up through here again. There's that guy. Yeah, that's fine. I don't care about that. Proofs, we don't need it. Just in linear. Right here. There it is. There it is. Look. Scalar component of u and direction of v. But they don't, they're just talking about the projection here. So this is different. Right here. This little guy right here is supposed to be our answer. Okay? I'm going to write that down. Do you see how I could have easily missed this guy? Look, this is your formula right here. And then they go right down to projection. Okay, so magnitude of u times cosine of theta. I'm going to write that down right now. So this is the scalar component of u in direction of v is magnitude of u cosine of theta. Okay. I want to see if that works. Is that correct? Do I get what they get, basically? So magnitude of u, already have it, square root 42, right? That's easy enough. And then they said times the cosine of theta. And so if you think about it, that is actually this guy. It says, what's the cosine? -1. So like it's actually the answer from part B. Right there. Negative square root 42. And if you go back to the answer, negative square root 42. So that's good. Wow. I'm sorry I missed that one, guys. But can you, can I catch a break on this one? It was like hidden, I guess. Anyways, thank you. Now I've only got like 4.0 stars. Oh, it's true. Thank you. Yep. Can we blame Amanda for editing it wrong? No, I'm playing. Yeah, she did a great job, of course. So okay, that's what I would say. Square root, negative square root 42, and then the projection thing. Do we have time? We got only 1 minute. I'm not gonna do it. We're gonna come back to this guy because he's a whole other discussion. It's a whole other concept that we haven't talked about yet. So we'll finish that up next time. You're all good. Thank you guys. I'll see y'all later. Peace out, homies.